All right, well, welcome to, I've just thought of a name for this, the Chemistry Cave. I'm in a little area in my house where I'm going to try to go over some topics for y'all so that you can get some help with your AMI work. Today I'm going to talk about Chemistry AMI Days 6 and 7 so you can get some background information about waves and properties of light and the EM spectrum and things like that, okay? So just in case you haven't signed up for Instagram yet, so that you can go see the video I have on Instagram about AMI days 1 through 5, you should be able to get to my Instagram on at Aaron Delau and see it's about an hour-long video that can help you with days AMI days 1 through 5. All right, so the first thing I want to talk about for the day 6 topics of EM spectrum is the parts of a wave. Okay, so the parts of the wave, so here's a wave, and I've got it diagrammed so that you can see the different parts of it. The high points of the wave are called crests. Okay, just like in ocean water, when the wave crests, it's the top of it, the highest point of it. Okay, and then the trough is the lowest part of the wave. Okay, now if you measure from one point of the wave to the same point on the next wave, that's called wavelength. Okay, so if I go from crest to crest or even trough to trough, that's called a wavelength. Okay, and that can vary. That's one of the things in a wave that can vary. They can be longer, like radio waves, or they can be shorter, like gamma rays. Okay, the midpoint, okay, that goes directly between the crest and the trough, that's called the midline. All right. Now, if you measure from the midline to the crest or the midline to the trough, that is called the amplitude. Okay. And that's this right here, or it could be this over here. Okay. So either the midline to the crest or the midline to the trough. That's called amplitude. And that can also vary for different types of waves. Okay. All right, now another thing that we need to talk about is the speed of a wave. Okay, in a vacuum like space, the speed of a wave is 3.0 times 10 to the 8th. So that's a positive number, so that's a lot of zeros, 8 zeros, meters per second. Okay, so 3.0 times 10 to the 8th meters per second. That's the speed of light. Okay, but it's the speed of any type of wave on the EM spectrum when it's traveling through a vacuum like in space. Okay, now that can be changed depending on the type of material or media that it travels through. Okay, so if it travels through a liquid, it will slow down. If it travels even through our air coming in from space, it will slow down. But it goes even slower in water, and then it goes even slower through a solid. Okay, so that can change depending on the media or the material or the substance that it travels through. Okay, but 3.0 times 10 to the 8th meters per second, the speed of light, is an important number, an important constant for you to remember. Okay, all right, now what I've done here is I've given a sad attempt at drawing the EM spectrum. Okay, so over here we have longer waves. These are the radio waves, and you'll see that they're spaced further apart. Okay, and then over here, yes, they're not the same height, so don't look at that. Okay, but going over here, then we've gotten to gamma rays where they are packed tighter together. They're closer together. Okay, so those are gamma. Their wavelength is shorter. Now, what does that matter? All right, well, let's see. There are 3 terms that we need to talk about. One we've already talked about, which is the wavelength. Another one is frequency. How many of those waves can travel in or past a point in a second? Okay, so seconds are the time that we use to measure wavelengths or frequencies, I should say. Okay, so over here, our longest wavelength is radio waves. Okay, the exponent for radio waves is 10 to the 3rd. So they can be thousands of meters long. okay? 10 to the third. So that's 3 zeros. That's 1,000, okay? So they can be really long. They're the ones that help us communicate with people, like pilots in an airplane, okay? Or radios in our cars, okay? The radio station will transmit, and then our antenna picks those up and allows us to hear the radio in our car, okay? Now, real quick, just a little side story. There's two different types of stations on your radio, okay? We're not talking about XM or Sirius, the satellite ones. We're not talking about those. We're talking about AM and FM, okay? So AM stands for amplitude modulation. Now, haven't we just had the word amplitude when I was talking about the parts of the wave? Sure did. Okay, so if you vary the height of the wave, that's the AM channels on your radio. You change that, and you can change the station in that you're listening to in your car on the AM dial. Okay, now if you go to the FM dial, what do you think the FM stands for? Okay, that's frequency modulation. So frequency is how many, okay, pass or are received by your antenna within a second. Okay, so frequency modulation. So you go from 108 or 107.9 to 88.1, okay, and you're changing the frequency, okay? So you can get 88.1 frequency, that is a lower frequency, versus 107.9, and that's a higher frequency, okay? So that is an example of radio waves, okay? Now, you may not have noticed, but, or maybe you have, that when we have like cloudy weather or storms or whatever, that the amplitude, the AM channels, are harder to receive, okay? Even the time of the day can have an effect on that sometimes. The mid, like noon versus the evening, sometimes the stations cut out in the evening, and it's because a lot of times there's like interference in the atmosphere that disrupts those radio waves from traveling, okay? Our next one is microwaves. Yeah, that's like microwaves in your kitchen can be used to heat up food because it's energizing the molecules in your food, okay? It helps to heat them up, all right? And that has an exponent of 10 to the negative 2. So now we've gotten smaller than 1, okay? So now we're starting to decrease in size, and that has an effect on the frequency, okay? Infrared is 10 to the negative 5, and infrared is like your body heat, okay? The goggles that like the military uses, or maybe even some hunters use, to help you pick up things like that and translate it into a visible form, okay? Because right next to that is the visible light. That's what we as humans can see, okay? Now, if you noticed, infrared, okay, is actually right next to the red visible light, and that's one way to help you remember the order that these things go in, okay? So longest is radio, because it travels through the atmosphere, our atmosphere, from one point of the earth to the other, okay? Microwaves, and then infrared, and then visible, okay? So it goes from red visible light are the longest waves, so that's on the radio side, and then the violet, okay, are the shorter ones that we can see. There's a lot more energy in the visible purple, the visible violet, than there is in the red. And then the energy and the frequency just keeps increasing as we go this way, okay? So next to the violet in the visible is the UV, okay? UV, ultraviolet. We can't see that, but other animals can. Like bees can see the UV light, okay? All of these are things that come into our atmosphere from objects out in space, the stars and things, okay? And they give off these different types of waves, like black holes and stars and planets. All of these things are releasing energy that travels to us through space, okay? Next is X-ray. Okay, X-ray, we've been able to use X-rays in like the dentist office and the doctor's office to help see through the soft tissue to get down and see what our bones are like, bone density, or if we have fractures or breaks, cracks. You know, we can see different things in our bones because of x-rays. Okay, x-rays were also very helpful in finding the shape of DNA, the double helix shape of DNA. Go Rosalind Franklin. All right, and then the last one is gamma rays. That's, you may remember that from when we talked about radioactive decay. Okay, radioactive decay gives off, one type that we've talked about, gives off energy. Okay, it didn't change the mass, didn't change the electrons or the protons or the neutrons, but it changed energy. It's still a type of decay, so we use the little gamma symbol with the 00, okay, to annotate that type of decay was occurring because the gamma rays were being given off as energy. Okay, so that's the last one. Now, how do these things travel? Okay, we got waves. What's traveling in that wave? Okay, well, we call them photons. Photons of light, photons of energy. So it's like these little packets. Okay, and so they're referred to as being able to travel as particles, which are the photons, and in waves. So it travels like this. Okay, now those have different properties. Okay, so the visible light is the one that we're going to concentrate on now. Okay, so that visible light has properties, and can some of these other things have it? Absolutely, they can have some of these too, but we're going to be talking about visible light right now. Okay, so properties of the visible light. All right, so the first property I want to talk about is reflect. Like you looking in a mirror and you see yourself. Okay, that's a reflection of yourself because the light is bouncing off the mirror at a 90-degree angle, and you're being able to see that. Okay, you can see yourself in the mirror. Now it's flipped, it's a mirror image. Okay, that means it's opposite, but you can still see a reflection of yourself. Okay, next is refract. Refract is when the light or the wave comes in and goes from one type of media, one type of material, to another one. Okay, so in my classroom I used to have this turtle tank. I don't have space for it right now, and that's kind of sad for me, but I had turtles in there, water turtles, like red-eared sliders and yellow belly sliders. I had them in there, and I would use that turtle tank as an example for this. Okay, you may have seen something like this when you have like a cup or a glass that you can see through and you have a straw coming out of it. Okay, so when kids would look through this tank, or you looking through your glass and you're looking at your straw, when my turtles would like snorkel up, it looked like part of them was displaced. Okay, and it looked bigger too because of the refraction, excuse me, of the light. It's bending, so that means its speed is changing, which is causing it to bend as it's going from one substance to another substance. Okay, and that's what happens when these waves come into our atmosphere and it gets interfered with from the gases in our atmosphere and the moisture that's up there, and it bends. Okay, so refract is the next property that we're talking about. Okay, next is dispersion. Okay, so this is what happens in prisms. Maybe you've never heard the word prism before, but you may have seen the effect before and not realized what it was. So maybe you have like a light fixture, okay, that has like these little dangly things, or maybe you've got some kinds of beads hanging somewhere, and they're clear, kind of like a plastic or a glass, and light can travel in, this bright sunshine can travel in, and it makes these little rainbows on your wall, bouncing around and stuff. That's because the light is traveling through those and being dispersed into little rainbows. Really cool effect, okay? You may have seen something like this even in a water puddle on the ground, where light shines on it and you can see like this little rainbow effect on it, okay? The key thing is the water is acting as the crystal that's helping to disperse the light so that you can see like the rainbow effect. Okay, so that's called dispersion. We've talked about photon. Okay, photon is being symbolized by a Y and a circle. okay? And it has this little ray of energy coming off of it, okay? Next thing we're going to talk about is electrons, okay? So why did I tie this into the electron unit, okay? Because electrons can produce light. When they get energized, when they absorb energy, they can get excited and go from the ground state. Okay, this is the ground state right here where all the electrons are down to the lowest possible level, okay, closest to the nucleus as they can get, you know, without breaking the off-belt principles and all that kind of stuff, okay? So they're in their ground state where they're at their lowest possible energy, and they can now absorb energy. So when they absorb energy, one of them out here that's absorbed the energy will jump up to the next energy level, and then it can't stay there forever, okay? Because at some point it's going to lose that energy, and then it's going to fall back down. And when it loses that energy that it's absorbed, it's going to lose it, and it goes through a process called emission. Now, some elements can, when their electrons absorb energy and then give it off, they emit that energy, they can produce light. Not all elements can do this, okay? But some can. So what they do is they fall back down and they produce a light, all right? So what's an example of this? Well, if you've ever seen fireworks, like magnesium, okay, element number 12 on the periodic table, it absorbs energy from the fire that lit the fuse, okay, and it's going up in the air, and then that fire, that spark, travels and ignites the magnesium, okay, the energy gets absorbed into the electrons, and then when they lose that energy, it's given off as a light, as a bright white light. Another place you may have seen magnesium is in a road flare, okay? They'll light or phosphorus can do this too. They'll light it and it produces this bright white light, you know, that's burning. Or if you've ever seen a movie where they have the road flares, or they shoot the flare, you know, the emergency signal flare up into the air, that's burning because it's giving off light and heat because of the chemical reaction where the electrons are falling back down from their excited state, okay? And they're going through a chemical reaction then, okay? So these are just topics to help cover topics from AMI days 6 and 7. And if there's something that you feel that I needed to go over again with you, you can get a hold of me on Google Hangouts, and I'll be happy to talk with you about it. If there is a topic from previous days that you want to go over with me, again, you can get a hold of me on Google Hangouts. I can talk with you. We can do a one-on-one Zoom like this. You just let me know what's the best thing for you, and we will do our best. I will do my best to help you be successful in this, okay? All right. I'll see y'all and talk to y'all again another time. Bye.